Welcome everyone to another of our online webinars. My name is Sean Zerbis. I'm the Director of BIM Development here at the CTC software branch. And today I'm excited to kick off a new series with you all. We're going to talk about Excel and a lot about Excel's essential formulas for use within a lot of CTC's tools. Now, of course, as always, our webinars are recorded so that you can come back to this in the future, use this as a reference anytime you're trying to leverage these types of formulas in our tools or just in Excel even, because this is just Excel common knowledge in this particular part one of this three-part series. Also, as always, we try to keep our eyes on the questions window. So if you have questions while we're talking about something in particular, please feel free to throw it in that window and I'll try to answer it in line. Or if I can't answer it in line, we'll save a section at the end for just Q&A for those of you joining us live. Without further ado, let's jump right in and talk about today's topic a bit. So here's the reality of things. Excel as a tool is really powerful. And I find it to be a critical companion to both the BIM and SIM suites offered by CTC. This allows you to do a lot of powerful data manipulation for things like Revit family types and properties and parameter values, as well as layers and Civil 3D standards and settings and pipe calculations. Across the board, it's just a powerful tool for this data manipulation, validation, and automation. The problem that I run into a lot is that a vast number of the formulas that are available in Excel can make it really difficult to know, like, where do you want to start your journey inside this Excel space? What formulas, what functions are actually necessary? So here in this webinar, I want to introduce you to what I consider to be some of the essential Excel formulas. These are things that you can use immediately when working with all of our tools. And Spreadsheet Link is probably a most notable tool that many of you are looking at here today. And the goal is that you're going to learn how these foundational formulas really work, how they streamline the management of Revit parameters and AutoCAD properties and values, and reduce manual data entry. So the consistency, the ease of use, the goal here is to improve that across Revit and Civil workflows. So we're going to talk through this in quite a lot of detail. I'm going to structure this session in a very specific way. We're going to start by talking about the general function structure in Excel. So when I'm using terminologies and we're talking about certain aspects of these functions within the Excel space, what even is a function? We're going to talk a little bit about this, that we have a solid core of what it is each of the next segments are going to talk about. Then I'm going to go through and outline what I consider to be the essential functions in Excel that really help to improve daily BIM workflows. Now, obviously, there's a lot more to this topic than I can cover in just one session, but we're going to go over the true essential functions that I think you need. Then we're going to take a look at each of those essential functions in quite a bit of detail. We're going to look at these commonly used functions. We're going to look at their structure, maybe even a few examples in the Excel space, so you can see how they work. And when I'm talking about the different, attributes that are in there, the different arguments that are in there in those functions, that you'll kind of have an idea of what that means and how this works in real formulas. We're going to use some pretty basic examples today, but in the next part two, we're actually going to use some examples directly out of Revit. And then finally, we're going to talk about some of the specific tools where you can implement some of these common functions. And again, in part two, we're going to dig even deeper and use some of those tools live in the webinar. So let's kick off right away. Let's start by discussing the general function structure and its general use and some of the common things that you'll see throughout most of these functions, okay? So in an Excel function, and here again, the rest of this, I'm going to be talking exclusively about Excel, but again, the goal is that we can translate this and use this directly in different CTC tools. Okay, so function structure. The first part of a function is usually going to be the equal sign. Then there's going to be a function name, and there's going to be something that happens. In this example, I'm looking at an if statement. An if statement, it starts with an equals in the Excel environment. You put the function name of if, and then there's a couple of parts that go along for the ride. Now, within this function, the first thing is the name of the function, if, on that top example. That's the name. There's other functions. There's things like left or right or find or I don't know, concatenate, right? There's different function names, and different functions have different individual parts inside of them. Now, between the parentheses of the function, because every function inside Excel is going to have the name and an open and close parentheses that pairs with it. Within the parentheses, there's different parts that you might need to work with. Now, those parts are called arguments. So in the if statement at the very top, you'll see the logical test. That is an argument. And then if that logical test does something, it's going to return a result like true or false. And if the value is true, it goes to the next part. That's another argument. What do you want to do if the value of the logical test is true? Or what do you want to do in the third portion there? What to do if the argument, that logical test, happens to be false? And any time in Excel you see an argument name that it's going to pop up with a heads up display. If you see that in italics, that means that argument is optional. You can choose to use it or not. That's up to you. But it is an optional argument that you can leverage for some extra power. But again, because it's optional, it's not required, right? That's the purpose of optional, right? That's kind of what it means. And then everything inside of a function, each of the arguments in the function will be separated by commas. You can see that in my little example there at the top. So if open parentheses, that starts the function, everything inside the open and close parentheses for a function is its arguments. The first argument, the logical test, then there's a comma that separates, that goes to the next portion, which is what to do if that logical is true, and then comma, what to do if that logical test is false, right? That's how that's going to function. And so that's just used to separate the arguments. Now, a lot of things that we do in Excel have something to do with some level of logic. I am doing a calculation because of some reason, right? I'm dealing with a door, and if that door happens to be in a wall, then there's that if word, okay? If the door is in a wall that has a certain property, then I want the door to do something special. Or I am looking at a room, and when the occupancy is greater than a certain number, I want it to do something, right? If you're using a term like if or when, then you got to think about to yourself, like, what am I trying to do? Why am I doing this thing? And if it's because of an if or a when statement, then write that down for yourself. Think about it. Think about all the criteria that has to be there for you to do the maths manually. And all we're going to do is translate that into Excel speak so that Excel can automatically make the decision as to what to do when it comes across that condition. Now, there's some logical operators that we use to help us with this. The standard operators are something like an equal sign. So don't confuse this with the start of a function. The start of the function is an equal sign as well, but that just tells Excel that the cell's value is going to equal whatever the function logic comes out to be. It always starts with an equals at the beginning of a function. But within a function, whenever there's some kind of a logical test, you can use something like an equals to say if 1 equals 1, do something special. Okay, that's one of the operators. The other operator, common thing that we use in maths here, is the greater than sign on your keyboard, on a standard Windows keyboard. That would be what? Shift comma. Oh, sorry, wrong. Shift period, right? That's the greater than sign. There's the less than sign. If something equates out to less than something else, then that could be true. There's greater than or equal to in Excel. It's pretty powerful. Less than or equal to. There's the not equal in Excel. That's greater than less than. That means not equal to. And then there's some modifiers that you can add with this, because sometimes it's not just one thing, right? If my door is in an interior wall, so the function of the wall is interior, and the fire rating happens to be greater than 20 minutes, then do something with that door, right? It's two conditions. It's an interior door, and the function of fire rating value is greater than a certain number. So we're doing some extra stuff. There's actually three operator kind of modifiers or collections here. It's and, or, and not. They in and of themselves are actually an Excel function. The and in Excel is an and function, and it has arguments. Or is an or function, not is a not function, right? That's what they do. But and will say anything inside its parentheses, all those things must be true. And you can have as many conditions in there as you'd like. So let's take a look at a couple of these real quick here. Let's just jump into and talk a bit more deeply about and, or, and not, because these can be really powerful when paired with other aspects of formulas. So I'm going to jump in real quick and talk about this. With the and function, it is simply a logical test. It's a series of logical tests, and an and function will either return true or false. That's all it does. It returns true or false, and. So logical test one, like 1 equals 1, that would return true. If I put a comma, my second logical test, 2 equals 2, that would also return true. And since both of those things are true, it would come back as true. Or in the case of this example here, and 1 equals 1, that would be true. 2 equals 3, that's actually not true. So because that is not true, that would actually return a value of false back to Excel. Okay. Second example, you could use cell references, cell addresses in Excel, and A1 equals B1, and then B1 equals C1. If both of those things are true, basically that would mean that A and B and C1 are all equal. If that was true, then it would return back a result. This doesn't have a result because I don't know what the value of those cells are, but we could test that in the Excel environment to find out what that would look like. So if I was to do something like this guy right here, this is an exact example of that, okay? Can I make that bigger? I don't think I can. Let's just double click into this. Oh, I have that set up as white. Let's go make that normal. Here we go. So this cell here is saying the same exact thing, and B3, looking at this cell here, equals C3, this cell here. And then it's separated by a comma there. So the second condition, the second argument is B3, this guy, equals D3, this guy. So if that is true, this function will simply return true. So if I hit enter right now, they're all nothing. So they're all equal. This nothing equals nothing, and this nothing also equals this nothing. So it's true. If I put a value in any one of these cells, it comes back as false because nothing does not equal 4. I could make that the same. This equals this, so that would be true. But this 4 does not equal the nothing of D. So that now still is coming back as false because this is an and statement. If I make it the same, it comes back as true. It goes, yeah, cool. They are all equal. Therefore, that is a true statement. Now, you can do the same thing or something very similar with an or, right? Or is also really powerful because I can say if this is true, or if this other thing is true, if the occupancy of a room is, say, emergency room or operating room, if that's the occupancy category, or something else is true, or it's in this certain smoke compartment in a medical facility, then do this thing with it. Calculate the occupancy in this fashion. Whatever, you could do whatever you want with that or statement. It's up to you. But if either of the statements there are true, the whole line is true. If either one of them is actually true. So an example would be or if 1 equals 2, or 2 equals 3, or 5 equals 5. This is 3 statements here in this case, 3 arguments passed to the or statement. And if any one of them is true, it will come back as true. And in this case, because 5 does equal 5, that would be a true statement, okay? And you can do this with cell references as well, just like the and above. And the final one here is a not. It's not this thing. The occupancy is not say 100 people or whatever. Like you could do whatever you want. So it's another logical test. Not, though, only has the ability to contain a single argument. If you need to do multiple nots, it's not this, and it's not this, and it's not this, you actually have to nest that within an and statement, but each not is its own argument. That particular function, this not function, accepts one thing, and that's all it checks. So not 1 equals 2, which is actually true. So 1 does not equal 2, it's false, but because I'm saying not, it actually reverses the logic. So sometimes you can use that to your advantage to reverse things. I don't use not all that much, but personally, I tend to use, 1 does not equal 2 with the greater than less than signs personally, but sometimes using a not phrase in there can be kind of nice. Just flat out using 1 greater than less than 2 would be false, or rather that would be true, sorry. Not 1 equals 2 is exactly the same thing. It's just a longer format way of writing it out with that particular operator. So again, you can combine these things together. This is one example. And 1 does not equal 2, that's true. And within that, I have a nested or where it says or 1 equals 1 or A equals B, and it can go through and run the logics on that, and basically both the first statement within the and, the 1 equals 2 being reversed into a not 1 equals 2, that would be true, and something in that second statement from the or has to return a true. 1 equals 1 in this case would. So this whole phrasing here would return true back as a result. Whatever the logic is that you want to run, no matter what it is, okay? Excel can handle that logic. You can give it all kinds of conditions. You can have all kinds of things chained together. The occupancy is this, the length of the total corridor is this for egress, the size of the opening has to be this, and if all these things are true, then do this thing, right? You can run all of these types of queries and put this in there. Okay. And one more time, anytime you see this italicized text, okay, that means that italics are optional. I can have a logical test 1 that is required in an or statement or an and statement or a not statement, the first one. But in the case of the and the or, you can have as many extra as you want. You can start with just 1, which would be kind of silly. Let's give an example, okay? If I did here, just equals this, okay? It kind of seems a little weird, but this in and of itself is a logic expression in Excel that comes back as true. The cell is running a formula that says B3 equals C3, that is true. Technically, if I wanted to use the and function, I can put the B3 equals C3 in an and function, and it gives me the exact same result. This is just a long format way of doing the exact same thing. The very first argument in there is required, right? If I delete this out and just put equals and, Excel's not going to know what to do with this because and requires something. So oops, didn't mean to click that. Let me hit enter. It's going to yell at me when I try to exit that cell. It says, hey, you didn't do a thing. Do you want me to fix this, right? Or you have to do something because I can't resolve this. So within that, I have to give it some kind of condition, equals that and that, okay? But optionally, notice if I hit a comma here, while it may not show it here, usually it does show it up on top there. These are actually optional statements. So I can have as many extra arguments in here as I want, which was this also equals that, right? So I'm doing B3 equals C3, B3 equals D3, both have to be true. I can have another one, I could do equals, and this is completely unnecessary because I'm already testing for this technically, but this equals this, right? You can have as many as you want. You can have a couple hundred of them if you really want to. That's okay, but you have to have at least one. So again, back over here, just wanted to refresh. Anytime you see italics in my text here, that means it's optional, okay? All right, let's move on and let's talk about the next thing here. So let's start talking about the essential functions in Excel. One of them is going to be a review because I kind of already talked about it, but we're going to talk about these all together here. So in the essential functions, the first one that I recommend you really understand well is an if statement. Now, if you've done any family creation in Revit at all, you've probably already written an if statement in a formula inside the family editor space. And the function, the structure of the if statement in Excel and the structure of an if statement in Revit is identical. Now, if you haven't done that, maybe you're a Civil 3D user and you haven't written a lot of these formulas, maybe you're not super familiar with Excel, if is a really powerful statement that I recommend you get your head wrapped around, because that is going to be a foundation for a lot of our logic. Because it's not, I don't usually just want to get a true or false on something, not usually. Usually I want to say, if something is true, then do this thing, or do something else if it's not true, right? So this if statement is really powerful. I also heavily leverage things like find and search, and there's different reasons why I might use the two of them. So find and search in Excel can be really powerful. Find like a colon inside of a string, and wherever the position of that is, do something with it. There's some examples where I do that, where I want to take like family and type names and separate them into specifically a family name or a type name, or find something inside a type name that looks like it maybe also has a colon and do some correction on that as a standard for naming conventions. There's a lot of things you can use this for. So find and search are really powerful. And then paired with find and search, very often I leverage something like left and mid and right. So those ones are nice because then after I find something in a string, I can keep the left side, or I can keep something in the middle, or I can keep just the right side of something. So you can use this to trim off certain things. This is a function, both find and search do not exist in Revit, and certainly do not exist in the Civil 3D space, really. So these are things that you can really only do in Excel, and this is why we like to take data from Revit or AutoCAD and pull it to Excel, because I can do things like this that other drafting apps don't really have the ability to deal with. Now, also paired with find and search and left, mid, right is the if error command, and I use if error all the time. This is a way to kind of catch something that Excel can't resolve. If you give Excel a condition and say, find me the colon in this string, and it can't find it, it'll give you back an error. And so you then have to do something with that to get back a real value. And if error is a really powerful way in Excel to sort that out. We'll see some examples of that here in a little while. And then we get into some mathematical stuff. A lot of the things that we like to do is get total calculations, count all these things, sum all these things, give me an average of these things, right? So sum if, and sum ifs, there's three different functions. They all kind of do the same thing, but they function in slightly different ways for different reasons. Those are a really powerful collection of functions that you can use. Similarly, count if, count ifs. Okay, you'll see a lot of similarities in these little maths functions here. Average if, average ifs. Okay, these are different ways of running those different types of functions. We'll take a look at those in a little bit here. And then finally, index and match. Okay, these ones are super powerful. If you can master this little collection of Excel functions, if you can sort of memorize a bit of how they work, these things are so incredibly powerful in Excel. I mean, obviously there's plenty of other functions in Excel that can work really well, but these ones, first off, work really well with the CTC tools, and secondly, give you so much power that you can do pretty much everything you want. Now, if Revit gave me these, I would be ecstatic, but they don't, and that's okay. That's what I use Excel for. So let's take a look at these in quite a bit of detail. I want you to be very aware of how each of these function work within the Excel environment. Starting with the if statement, because again, this is so foundational. If you don't get this, you're gonna have struggles in all other areas, but every function kind of really works kind of in the same way with similar logics, depending on kind of what it's trying to do here. So the if function. I showed this earlier, I'm going to show it again. The if statement is the if function here. It starts with if. Doesn't matter if it's caps or smalls. Excel by default will always capitalize function names, and you're seeing in my little PowerPoint presentation here, I'm doing the same thing. Within the parentheses, there's 3 parts. And technically the result if false is optional, but I didn't mark it as such because I don't personally consider it an optional thing. You should really always be handling the false statement in the Excel space. So there's a logical test. This is anything where something equals something else, or you're doing like an and phrasing there. This and this are both equal, or this is equal and this is not equal. You do whatever you want with that, but you have to give it some kind of a logical test, and that test must somehow return true or false. That is what an if statement wants. That first part, it wants a true or it wants a false. 1 equals 1, that's true. 1 equals 2, that is not true, unless of course you're a maths major and you want to argue that 1 equals 2. Like that's a different conversation, all right? In Excel, 1 does not equal 2. Depending on whether that logical test gives you true or false determines whether the if statement does the second part or the third part of that phrase. If that logical test is true, then it will do this next little phrase right here, this next little argument. If that logical test turns out to be false, it does this last portion. It completely skips the true statement and will do the statement that you're telling it to do if that logical test is false. That is how an if statement functions. So give me a test, 1 equals 1, it's true, great, do whatever you tell me to do here. Logical test, 1 equals 2, it's false, great, skip this, go right to the end, do this thing. And that's all it will do. That's exactly how an if statement functions. And whatever you choose to do inside the do if true or do if false phrasing is up to you. You can have functions on functions inside of there to achieve a complex result, but at its simplest level, an if statement is that little basic thing right there. Okay, so here's an example. If A8 equals B8, that's the logical test. If that ends up being true, I'm going to tell it to actually write back to Excel true, which is kind of silly, but I'm telling it to do that. Okay, if that ends up being false, then it writes back whatever the false statement is. Let's try it. Let's give it a test. Down here, we're going to do, oops, hit escape here. We're going to do just a basic if right here. And so in my calculation, I'm going to write the formula out. Equal, oh, it's all, good Lord, hang on. Let me, let's make this all normal text as well. There we go. Okay, equals, I'm going to put spaces here so you can see this. If, doesn't matter if it's capitals or smalls, irrelevant, because Excel is going to always return the function as capital when we all get done with this. And notice how Excel has this really cool heads up display. This is nice because you can see other alternatives of the if statement that you can also potentially use, like if error, which we'll talk about in a little while, if NA or if S. There's different options of how this works. Now, when you're taking a look at these different statements, read the little portion there on screen. That's going to be highly valuable because it'll tell you what it's going to try to do. In this case, it checks 1 or more conditions. So if S can be kind of a powerful thing sometimes, so you can avoid some of the nested if statements. But I like to personally stick with just if because it's the most basic and it's easiest to use. So I'm going to talk about that specifically. So if, open parentheses, you're going to give it some kind of a condition. If this equals this, some cell references, whatever. That's the condition. I'm going to put a comma, and then I'm going to tell it here what to do if that ends up being true. So I'm just going to put text. This is true. Okay, just text. And then I'm going to put a comma, and I'm going to tell it to what to do if that's false. So quotation mark. Actually, if I hadn't put a space here, this would be starting to give me some heads up displays and tell me where in the if statement I am. This, by the way, can also be really valuable. So logical test, value of true, value of false. It shows me where I am. It actually highlights in bold where I am. So when I get over here to the value of false, if false, I can actually kind of keep track. In Excel, this is really powerful. So I'm going to put this is false. And I happen to capitalize the F on false, and that's whatever, it doesn't really matter. So when I hit enter right now, because the check is B and C, right now they are the same. So this is true. If I put a 3 here, it turns it into this is false. 3 does not equal nothing. Or if I put a capital A, it goes this is false because 3 does not equal A. If I come back and put a capital A, it goes, hey, this is true. If I put a lowercase a, it's still true because it doesn't care about case. All it cares about is that it's the same letter in this case. So the if statement is case insensitive, just to be clear. So I could put, word, and I could put word, and that is still the same thing because Excel in the if statement, the calculation of one equaling the other equals here in this case is just the letters, not the capital status of the letters. So important note there. So that is a basic if statement, and you can use that for a lot of different things, okay? So the logical test, just a couple of notes again, I mentioned this earlier, I'll say it again, that logical test, that first part must return a true or a false. That's what it has to do. So it can't be just a string of text. The logical test isn't word, it's word equals word. It has to, be an equality of some part or a greater than or less than or not equal to kind of thing so that it can return a true statement or a false statement so that the if phrasing can do what it's supposed to do. You can absolutely leverage and or not functions to build much more powerful logic, okay? Got a couple of samples here. You can nest additional if functions also to get even more powerful logic if you need to. This is an extreme example. Well, not really that extreme. This is actually pretty basic, but I'm doing a logical test on A8 equaling B8, and then if A8 also equals C8, then it does something with that, or it puts something else in there. If A8 doesn't equal B8 in the first place, then it just checks to see if A8 equals C8, and if it does, it puts a different piece of text. Otherwise, it doesn't equal anything. I built a similar example up here in my Excel file with this nested if statement right here, where depending on what text I put in here, if I put 0, 0, 0, it basically is telling me that, why did I put A? I meant B. Doesn't matter. I didn't actually have a really good check here because it doesn't know what to do if they're actually all exactly the same. But if I put 1, it'll tell me that B is the largest value out of all of it. If I put a 1 here, then it'll tell me that C actually happens to be, B, because it's checking against B, happens to be larger than some other value. And I might have put wrong references. Yeah, I put larger than C. It should have been larger than D. Look at me not putting the right text in there. Larger than C. Yeah, perfect. Oop. Got to correct my text so it actually says the right things. Otherwise, it doesn't say the right things. There we go. Yeah, so it's checking for the value of B specifically here, and B is larger than D. It's equal to C, but it's larger than D. If I was to make them make B smaller, maybe I make this 3. It'll just say that actually B is supposed to be the smallest, because again, I had the cell references off. I inserted a column over here and screwed up my letter references there. But it's trying to figure out like what's going on with the actual comparisons if it's larger than something or equal to something in this case. So you can have multiple nested if statements in here to figure out, in this case, and both are bigger, or just one is bigger, or the other is bigger, or nothing is bigger, then it tells you all the things that it's supposed to say based on your logic. And obviously, you have to be very careful about your logic, because in my case, I'm only checking to see if something is greater. I'm not checking to see if they're equal. So if it's not greater, but it is equal, it still tells me something is bigger, because it doesn't know about the equality of things because of how I wrote my logic, okay? So make sure you're testing whatever it is you write out, but you can have these nested if statements, but they're all still individually a simple if statement. This if statement right here is just an if statement. That's it. If I get rid of that particular if statement and I just put in here false as a piece of text, this is just an if statement. That's all it is. If I get rid of that, this is just an if statement. They're all just simple if statements. I'm just using another if within the false statement, okay? So yeah, there's a lot you can do with that. That's really powerful. And just understanding that you can combine functions together is probably one of the biggest takeaways if you're already familiar with some of the core function features. Let's take a look at another one here, find and search, okay? Find and search are really powerful. They work almost the same, but just a little bit different. I want to explain what that difference is here. So when you're doing find specifically, you're going to give it some kind of a value. Now, this isn't an equality. I'm not trying to say true or false. I'm trying to say look for a certain value and look for that value in a specific string. And here you're seeing one of those optional values, this starting position, because I can tell it to find something in a string, but don't start right at the beginning. Maybe start 3 or 4 characters in. So you can actually tell it like where in that string to begin. But that's the core structure of this. You're going to find something in something else. And this is all about strings. This does not, the find function does not allow for any kind of wildcard characters. So you can't say find star a star in something. You're just going to say find a in a string, and it'll try to find that. The find function, very importantly, is case sensitive. I want to mention that because earlier I was talking about the if statement, how, you know, capital W, lowercase erd in the word, right, is the same in an if statement for equality as all capitals word. But in the case of find, if I was going to find a capital W or a lowercase w, that is different. They are different characters. So you have to be aware when leveraging find that it is very case sensitive. Now let's talk about search. They are almost the exact same thing. You look for a value, you search for a value, you're searching for that value in a string, and you can specify starting position. The only difference is the function that we're using is find or search. But the difference is search does allow for wildcard characters. So here I could say find D star R, and it would find door or drawer because both start with a D and end with an R, and it's going to find that string inside of there. So for the value, you can actually leverage wildcard characters if you want to. I'm not going to talk in depth about wildcard characters. That's a little bit beyond what I typically use for this, but understand you can do that, whereas in find, you cannot do that. The other thing that this does is it is not case sensitive. So I could be finding a word where it's capital D or lowercase d. It doesn't matter. Star R. It doesn't matter. It doesn't care because it's not case sensitive. It's just looking for the letters or numbers. Okay. So let's jump in and take a look at a bit of an example here. I can search using search, which again, not case sensitive. I can search for anything that would be T dash asterisk, which actually isn't really that needed, just because I don't need the asterisk. I could just do T dash, but what it's going to do is find anything that is T dash, whether it's capital or small, and in this, it's going to find this lowercase t dash and anything after it, and it's going to tell me that it found that T dash at the 4th position. So 1, 2, 3, 4th position is where it found T dash. It uses the first letter that it finds for the positioning. So it's going to return you back a result. And that's the interesting thing about find and search. What it gives you back is an integer position within that string where it specifically found the thing that you asked for. So that's what search returns, that's what find returns, okay? Now, this can also return an error if it didn't find the thing inside of here. It wouldn't return a 0, it returns error, and you have to find a way to handle that. If you're trying to find something in or search for something, you have to build in some kind of fail safe in case it doesn't find it. Okay, combined with that, I often do left, mid, and right. And this is a way of trimming strings down, either keeping the left, keeping something in the middle, or keeping the right. And that's kind of what these functions do here. Left, mid, and right as functions. You basically give it some text, you give it a string of some sort, and you tell it how many characters you want to keep. That's what left does. It keeps the left side for the number of characters in that string, and that's exactly what that's all it's going to do. It keeps the leftmost characters. Right is identical. You give it a string of text and you tell it number of characters, but this one keeps the rightmost characters, keeps the right side of a string, depending on how many numbers or integers you tell it to keep, or values to keep. Mid's just a little bit different. You tell it the text, you tell it where to start keeping text, and then how many characters total to keep inside that string. So you'd say start at position 3 and keep 5 characters, and that's what it does. That's what mid will do. But they're all just ways of trimming down strings to get back a value that you want. Okay, so an example would be if I tell it A, B, C, D, E, F in Excel, and then I say keep 3, it'll keep ABC. That string is what it's going to return back to me. It'll keep the ABC. Or if I say right, same thing, A, B, C, D, E, F, 3, it'll keep D, E, F. Or if I say mid, A, B, C, D, E, F, start at number 2 and keep 3 letters, it keeps B, C, D. It starts at the second letter, which is B, and it keeps 3 letters, B, C, D. So that's what it'll do. That's how that particular function works. And this has a lot of different uses, but one that I use pretty heavily is something like right here. Let me just make this normal. So I've got a little left function here, and it's looking at the value of whatever's in B6 over here. It's looking right here at this cell. Whatever's in that cell, it's going to try to find a colon, and if it finds the colon, it's going to return it's using left, it's using the string of B6. Within there, I'm trying to figure out where the colon is, and wherever that colon is, that's how many characters I want to keep -1, because I don't actually want the colon. That's what it's effectively doing. Now, if it doesn't find a colon, it returns absolutely nothing. So if I just go over here and put in text, nothing actually happens because there's no colon. But let's just say I do something like family : type. Okay, what this will do is it'll return family because it finds the colon and it goes, okay, 1, 2, 3, 4, 5, 6, 7. At position 7, I found a colon, and so it's going to take that 7, subtract 1, that'll be 6, and it tells it then for the left, keep the left text, keep 6 characters on the left side. For the first left, the 6 left characters, leftmost characters. So it returns family, right? If I wanted to reverse that, I could say, hey, do right and find me the first character. But here's the deal, it's gonna start at that colon. And what I probably wanna do is subtract, I don't know, maybe 3 characters from that. Yeah, there we go. So then it's gonna give me back just type, the word type. So it strips off the entire first part of colon, space, and the word family, because I told it just keep the right stuff to the right, to the far right, keep those characters, and it goes, okay, cool, we're keeping that number there. All right. So yeah, that's one way to find something. That's actually not the best example. This isn't how I would do the right half of this, but regardless, it works for this little example here. Okay. So let's take a look at one other part that I had in there, which was the if error. I already kind of showed it, but let's take a look at this if error function. So if error, what I do is I give it something. I give it a value of some sort. And if for some reason that value is an error, then the if error will just say, we'll default to this other thing. It's as simple as it is. Now it's nice because I can use this in logics where if the logic completely bombs out, it can't find a cell reference, it can't find a string or search for a string inside of another string, something crazy happens, instead of it giving me this really nasty, error or pound ref, it'll just say, oh, I'm gonna give you this value that is there if there's an error that shows up. And so it's kind of like a default little error catch. You can have it do something a little bit different. So I do that quite frequently. It's a fantastic way to error-proof entire formulas or just small parts of formulas in certain cases. This helps make a lot of your formulas way more predictable. So there's a lot of times when even I'm not typically expecting an error. You know what? When you pull stuff out of a Revit project model or you pull stuff out of the Civil 3D environment, you can't necessarily know that every piece of information will have been filled out the way that you expect. So you need to find a way to catch that so that later on when you try to push things back into Revit or try to push values back into Civil 3D, that you're not pushing in Excel's favorite little piece of something that looks like this. So if I say find, I hid way too many things in my little Excel formula here. So equals find colon in string. Okay, this is going to turn back with pound value. Well, I don't want pound value exclamation point to get pushed back into my Revit project as a string value. Or I don't want to get pushed back into Civil 3D as the name of a layer or something. That would be silly. So instead of trying to push this back in, what I do is I wrap this in an if error. If error, do something, and if this results in an error, then do the final part. Otherwise, just give me the value of this, right? So if I say, if there's an error, put nothing in that cell. If I'm telling you to find something and you can't find it, just don't error on me, do nothing, or give me a value of 0, maybe, 0, I didn't find it. That might be a good thing to do, right? So you can do that and then it'll go, okay, 0. I didn't find the thing, 0, it's at 0 position. So then it'll do whatever with that and whatever I'm going to use it for. So this way, even though this would return an error, the if error catches it and says, okay, this is what you're getting back. That's really powerful, okay? This is also a really powerful way to get rid of anything that might come back as pound NA or pound ref, or sometimes it's not error or value, it's something else, right? But Excel has different things it'll throw back, and if error will catch all that stuff. Really powerful way to work, okay? Another example, if error, search A in something, that would return an error. And instead of returning the error, I'm just returning double quotes, which is nothing. It's an empty cell. It's a blank value. So a lot of my formulas actually work that way, where I say return nothing. And it's a null value, it's a nothing value. And when you try to push that back into Revit or you try to push that back into Civil 3D, you just get nothing in that value. It won't even initialize the parameter for that object if it was already empty. It'll just leave it because it has nothing to push, nothing to change. So it's a really powerful way to keep your data, especially when we're talking about exchanging with Revit and Civil 3D, really, really clean, okay? All right. Some of the other common functions here, sum. This is an additional style function, okay? Sum if, some ifs. The way that this works is you're basically just gonna give it a whole bunch of things and it will add them up. Now, why is this useful? Well, instead of you needing to do this cell plus this cell plus this cell plus this cell plus this cell when you're trying to get a total of something, you can just say sum all these cells, and it's way faster. Sum 1, 2, 3, and it's separated by commas in this case, those are individual arguments, or sum a range of cells, or sum a range of cells and some other cell or cells. The nice thing you notice here that the first range is required, the first value is required, but then everything after that, you can have as many ranges as you want in the sum function. As many as you want, okay? So like one of the easiest ways to do this, if you highlight a bunch of cells in Excel, there's this auto sum button right here. What this does is actually run the equals sum command. It goes, okay, cool, sum D3 to D4. But all it is a sum function. It's a shortcut to that sum function. So if you were like sum D3 to D4 and these cells and these cells, cool. Now it's going to give you the sum of all of these cells right here. Another way to do that would be you could just start at the beginning. Well, let's just get rid of this. If they're all contiguous cells, you could just do this here, and it'll sum them all up and give you the same results. You can even avoid commas if that's something that you want to do. But sometimes, usually there's separations in that case. But you can use that sum function. It's really powerful. It's way, way more efficient than equals this plus this, plus this, plus this, plus this, plus this, right? This will achieve the exact same result, but sum is just easier to write and easier to read and easier to maintain over time. So sum is a really powerful thing. It's just an addition is all it is. Now you can also run a sum if command. Sum if is really powerful, where you say, give me the sum of these cells from this range. So the structure is the same as sum for the first part, give it a range, and it'll sum it all up, only if some criteria is met. So this is kind of like an if statement. Sum all these values if it is in a department that equals administration. Great. So if the department equals administration, sum it. So I can give it a huge range of things and then run some extra criteria on some other cell, and if the values match up, it'll give me the summation. That way you don't have to be picky about this cell, this cell, this cell. It sums it automatically if some other cell matches some kind of criteria. And so here's another good one. Only add up things if the value is greater than 5. So cull all the values less than 5. Or sum all these values, sum all of the areas of a room if those rooms are on level 1. Great. That's really powerful. Okay. So you can do other things inside of here where within this, the criteria that you're passing it and the sum value, if you're giving it that extra criteria and you're not giving it that third sum range right here, that third field, what this function will do is sum all the values in this column, which is why this works. These are all numeric properties. And if the value in each of these cells is greater than 5, then it sums it up. Fantastic. Over here, the range that I gave it is actually strings of text, which you can't sum. In fact, the strings of text are names of rooms, or names of levels rather. So if the value matches level 1 in a building, then it'll do the sum, but it can't sum this. You have to tell it what column to actually do the summing on. And so then here I'm going to give it the range. That's this over here, the range to sum up. And you can give it multiple ranges here as well. So it's actually going to take a look at this, compare the value, say, is the value of one of these cells level 1? And if so, sum up the values that exist in this other column. That's how the sum if runs. The third option, and the one that I personally use most, is the sum ifs, because I don't like it when the summed value is the first column, and then down here in sum if, it could be the first column unless that's text, then I have to give it a sum range over here, and it moves where my actual summed values are. That kind of bothers me. So instead, I typically leverage this sum ifs where the range that I'm summing is always the first column. And then I give it the criteria range. In the case of sum if, this could be the criteria range, or it could be the sum range, or it could be both, right? So down here, this is always the summed range. Sum ifs here, the criteria range 1 and the criteria for it, those are two different arguments you pass. You pass it a series of cells, that is the cells to check against, and then you pass the criteria to check. That's kind of similar to this over here. But the difference is, if I wanted to check this same exact thing here is written out actually this way with some ifs, the S, the plural check. So here I'm saying sum this up if the values in this column match level 1. So I do this because now if I really wanted to with sum ifs, I can give it additional criteria ranges. I could say sum these values if it's on level 1 and the department column matches administration, and this other thing holds true, and it's not an unplaced room, and something, 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 right? So I leverage some ifs a whole lot more just because I feel better about its structure than I leverage some if. And you'll actually see that pattern continue with most of the other things that I do as well. So yeah, here's another example. If the level 1 and it's a studio apartment, for example. So I'm going to blow through the rest of these because these are all pretty similar here. Count is very much the same thing. The count function, you give it a range and it'll count up the total numbers in that range. 1, 2, 3, 4, it just counts them up. So count 1, 2, 3, or count A2 through A5, or count these cells, and you can give it multiple ranges and it does a count. There's a count A, which is another type of count, which that one, okay, sorry. So count A is actually a text-based count. Count is text or integers, but I like count A a lot because count A is actually alpha characters and it counts values inside those cells as opposed to what it does in the trying to count up numbers up here. There's also count if, which again is a lot like sum if down here. And then there's count ifs, which is the way that I prefer to do it just because of how it functions. So that's how I personally prefer to use the count is count ifs or a count A if I'm just counting one thing, how many things exist, okay? But usually it's how many things that match a certain criteria, count all of the studio apartments on a level. And so I would give it a criteria range of the department or the name or the type of unit with a criteria to match it. And then I would also give it like a level column with a level value to match it. And all these don't have to be cell explicit text pieces. This studio value could come from some other cell reference. So yeah, there's a lot of ways of leveraging this, but the goal is to get a total count of something that matches certain criteria. And usually I will be using count ifs for most of my counting operations, just because then it's consistent 100% of the time for me. So there's one of those examples. Count all the things on C column that match level 1, all the things in the D column that match studio. Ready to go. Okay, so average. Averages are powerful. What's my average square footage? What's my average height of rooms? There's a lot of things you might want to do averages on. The average cut and fill of dirt. There's the average elevation of pipe. There's a lot of things you might want to do averages on. And so again, average has multiple ranges for just base averages. Here, average 1, 2, 3 would be an average of 2, or an average of a series of range of cells, or multiple cells. Again, that sort of structure holds consistent for average, just like sum and just like sum ifs or count. There's an average if, and again, I typically don't use average if because it changes my structure too much. When I give it a range and a criteria, if that range is not numeric, then I have to put the average value range at the end, and I don't like that. That doesn't sit well with me. So I will typically use average ifs because my range is always first, the very first value, just like an average. And then I can give it the criterias here, the average range criteria and the comparator, different criteria, different comparator. So I can do things like give me the average of the area for all rooms on level 1, for example, or all rooms of a certain type on level 1, because with this you can have as many extra pieces of criteria as you'd like. And I'm usually using more than one. So just as a standard, I will do average ifs, and that's not supposed to have a space. So my apologies about that. Just noticed that was there. Okay, I'm going to get to the last 2 functions for this session that I'm going to cover in a bit of detail. And this I'll probably give some examples inside the Excel space at the very, very end for those of you that have time to hang out for some of the Q&A and the extra little content here. This is where we start to talk about index and match. Now, some of you may have leveraged the, what is it called? Lookup. VLOOKUP is what it's called. I personally do not use VLOOKUP at all. Initially, you will see a very close similarity to index and match, but it's not the same. It is not as powerful. So I like using index and match because it is way more powerful personally. Indexing is a way of looking for values from other tabs of data. When you're pulling data out of Revit, when you're pulling data out of Civil 3D, sometimes you need to look to another tab and find a specific match for some data so you can marry it up with some other calculation. I need to index all of the pipes that are of a certain system, and I need to get their slope values or their total volumes or their total weight or whatever. I need to find or index for a certain level to get its exact elevation to pull that value back. There's a lot of reasons why I leverage the index function and subsequently the match function. What index will do is it will take an array of objects and it returns you the values from a specific row number and column number. It returns a value at an index, at like an address, okay? It's like an XY position and finds the exact property. Maybe I'm looking for, if I'm doing something in airflow, maybe I want to find a next size to noise cancellation or noise rating property, and I want to find what that airflow velocity is for those two values, right? That's a lookup of two different things to find that intersection of an X and a Y position. Index helps me do that. It's a really powerful lookup or VLOOKUP function. The array specifically can be one column with a whole bunch of rows. It could be a whole array of columns and rows. It could be many columns in just one row. It's up to you how you want to use this. This index can be used in any of those dimensions, but it's so powerful. That's why I use it over the VLOOKUP or lookup function. So I can index a whole bunch of stuff and return anything from row number 2. Let's build up a micro data set over here so we can kind of dabble with this just a little bit. How come Excel? Oh, that's why it's being silly, because I'm in the middle of a formula. Let's have A, B, C, D, and let's do 1, 2, 3, 4. Okay, and we're just going to put some random values in here. I'm going to do I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, super simple. If I'm trying to find the intersection of C and 3, that would basically be the value of 11. Index helps me get there. I can tell it, if I give it a full data set here, I can tell it to give me row 3, column 3. And when I do that, it'll return me back that value. So that would look like this, equals index, all of this stuff, give me back column 3, sorry, row 3, comma, column 3. And it'll give me back exactly that value of 11, okay? Give me back row 1, column 3, and it gives me back the value here of 3, okay? So it's looking through this array of stuff, and it's finding me the row, and it's finding me the column. In fact, I'm gonna change this here to E, F, G, H, just so that it's not numbers over here. These will be text-based values, and we'll look for that here in just a moment when we start to talk about match, okay? So that is one way of using this. You can index a whole collection of data and tell it to return back. In this case, this is one example where it just returns the row of something. So if I wanted to index, say, this and say, give me row 3, I could do that. Index well, we'll just do this and return back to me row 3. That's it. So if I double click index, this whole column of stuff, 1, 2, 3, 4 rows of data, and I'm telling it to give me back row 3 specifically. Technically, the column isn't required. That is an optional field And when you're using only one column of data for your array or one row of data for your array, it's nice because you can just skip putting in the column value. I don't need to tell it column 1 because it's only got one column of data, and it will automatically give me back the value from the first one, which can be really useful sometimes, okay? So also, I can do column and row and column at the same time. So give me a full array that's multi-dimensional. It's X and Y direction. That was the first example I did where I return a row and a data from a specific column, and it gives me the specific value at the cell at row 2 and column 5. So that's a really powerful thing. Now, what a lot of the times you will see happen is people will marry this up with the match command. So it's index and match at the same time. This becomes incredibly powerful because now with the match function, I can tell it to look for a certain value in an array and give me back the position of that value in that array. And that array can be either columns or rows. It can't be multi-dimensional, it doesn't like that, but it can be a really powerful way to find a row of data in a whole column or a column in a row. So the problem with the lookup array or VLOOKUP, it can only use a single column and a single row. Lookup array specifically, this value here can only be a single column or a single row. So be very careful not to make this multi-dimensional. It wants to look in a single straight linear direction and find the value in that direction, either from left side to right side or from top to bottom. That's all it's gonna do. It goes in one direction, that is it. And so it'll give you back the row or the column from that lookup. So top to bottom or left to right. The match type defaults to a 1 up here. So I typically specify 0, which is a quote exact match. Whatever you tell it the lookup value is, whatever that exactly is, it will try to find it in the array if you specify 0. 1 is like a soft lookup. Like if you gave it a number 0 and you had a number in Excel that was like 002, it would actually find 002 because it did like a soft match and it went, oh, there's a 0 in that, so I found it and gave you the wrong row of data. So I pretty much always specify 0 for my match type, even though it's technically optional, it defaults to 1, and that's not usually what I want. So I always will personally specify that. And if you want to know more about the match type, definitely look up in the Excel help documentation. But for our purposes in both the building information modeling and civil information modeling side, usually we want an exact match. I've very rarely seen fuzzy maths work really well for us. And by the way, the lookup value up here, this does accept wildcards. Find a star or a dash star or something. You can do that to find things, so it's not an explicit, and that will work even with the exact match. It still works with wildcards if you explicitly specify that in the value. So a couple of examples. Match the string of unit A, find that in the column D2 to D5 with an exact match, or specifically match L star in A2 to G2, and it'll try to find that. It probably what it would find is the level value to figure out where that is. And so an example here would be, if I go to this, I can say equals match the value of E, match E in this range. And it'll go, cool, fine, it's the first row. That's row 1. It's not finding this, it's finding the row where that is. Similarly, if I said match G, it's gonna go, cool, G is in row 3 from what you had selected in your array. My array is this right here. So row 1, 2, 3 is G. That's what it returns is G. So if I'm trying to find G here, I can tell it to match for G. Instead of matching an explicit number, I can actually have it find something. So I'm gonna say over here, I'll put the letter G and I'll put the letter C for now. And right here, I'm gonna update this index phrasing to say, well, find for me, match the G value, G8 in this case, the value in that cell, and find it in this array. And so what it will do, I can change this to H, and it goes, cool, I found the H. What it's actually doing is it's indexing the array that I gave it and trying to return a value from whatever row this comes back with, and the row that it comes back with happens to correlate with the H. Now I could tell it to find me a value out of a specific different column of data, like find me the value out of this column over here specifically at whatever row matches this data over here. So when I say, give me the value out of this column from H, it goes, cool, that value is 16. Or give me F, and it goes, cool, that value is 8, because it looks and it figures out where does that correlate for the F row from this data set, and it returns that same one from this data set over here. Now, you can really combine that in even more powerful ways with index and match, where you can do stuff like indexing a full two-dimensional array, X and Y. You can match a value at a particular known column. You can specify the column if you want to. This is an extremely powerful way to pull values out of a table, and match can really provide that row address. That's the most common way of using this, is to provide a row address, especially when your columns are stable. The column can also be returned by match if the data happens to be moving around different positions. That can be really powerful as well. So I can go into Excel over here and I can tell it, you know what, for this index, instead of just being a single column lookup, look up all of the data, find me the row that matches this, but then I can tell it also, find me the column that matches this from this index right here. So now match is doing two things. It's finding me the row in one direction, and it's finding me the column in the other direction. And from my entire index, this big data set, it's returning me the row and column that matches a specific set of criteria here. Really powerful in data sets that sometimes might move around. So now I can say, well, give me A, F, and it goes, cool, that value's 5. Give me CH. Cool, that value's 15, CH. And it's doing a lookup to find a very specific set of data. So now I can pull information out of Revit to multiple tabs. Maybe I'm pulling doors and rooms and walls and levels, and I can then use that on another tab that I personally put together to find all of the doors that match certain criteria on certain levels and do something with that, marry that up with rooms data on those same levels, potentially marry it up by the coordinates. There is so much you can do now with index and match, because I can look up information off of as many tabs as I want to and rectify that on a single tab. Maybe you want to do code compliancy checks. I want to know how many total plumbing fixtures I need by level in my building by total occupancy. Well, you can use sums of total occupancy, limiting that to certain levels. You can structure that in a way to do some maths and say, well, if the value is less than a certain thing, make sure I have at least one plumbing fixture for the men's room and the women's room, right? There's so much logic now you can build in, so you can do all kinds of calculations automatically from data extracted from Revit or data extracted from the Civil 3D space, because index and match plus the sums plus if-then statements plus potentially averages or whatever, the count of things, there's a lot of stuff you can do with these core functions that are so incredibly powerful. By the way, you can also use match to look up multiple values if you really want to. So one example is match, where is this here? No, that's not the one I was looking for. This one, this is a good example, really complex one. Indexing a whole big data grid, matching anything that happens to be on level 1 and level 0. So it's matching both of those things. And then it's looking for anything that's studio and matching up the name being something specific in an area that is something specific, right? Like it's doing a bunch of checks to find the exact address of something to return something back from that index of grids. So powerful little data collection here. Now, beyond the scope of this webinar, because we've already gone well over time here today, beyond the scope of this webinar, there's a lot of places we can use this, and this is really where part 2 comes into play. For the BIM suites, Spreadsheet Link is a really powerful tool, and all of these functions and formulas work really, really well in Spreadsheet Link. Fire ratings are a powerful way, code compliance checks, ASHRAE table 62.1 calculations, let's see, residential unit reports for residential modeling. All of this can work really well for those types of calculations and more. I often pair this up very heavily with Spreadsheet Link and Schedule Excel. I marry the two together so I can pull information using Spreadsheet Link and run calculations on it, heavily format with those calculations, and then turn around and do things like plumbing fixture calculations, bringing that back in graphically into my project in a way that Revit can't even represent. Those will be some examples we'll talk about in future sessions in this series. In the civil side, Earthwork Processor has some really powerful things I might do with this, where I'm doing like area conversions in Earthwork Processor or calculations in Earthwork Processor. Maybe I'm recalculating volume requirements based on rules that I want to run and pushing that data back into the model. Or if I'm doing things with Pipe Planner, maybe I want to do pipe invert and sump elevation calculations, where maybe my sump depth is always going to be, 3 feet below the invert or 5 feet below the invert. Well, I can do that automatically. Instead of manually typing values in, I could run some basic calculations on the sumps based on the incoming pipe invert and have that done in Excel and then push it back in. Or if I understand what the flows are, maybe I want to do some pipe sizing in Excel and then push that back into the Civil 3D space with Pipe Planner. Or maybe I'm doing unit conversions on point files when I get point files from the field, or I'm doing things coming from, say, LiDAR scans where everything is in metric and I want it to be in feet and inches. Or maybe the XY is in feet and inches, but the elevations are in meters. Well, I want to do unit conversion so I can get proper scaling on my point import. Unit conversion here is something really powerful I can do in Excel very easily, and then use that as my source file to dump that back into Civil 3D as I'm building my terrain model from some sampled LiDAR data, right? Tons of really powerful examples here of how you can use these exact formulas that we talked about today, simple formulas beyond just basic this plus this or this times this or this divided by this. This is a couple of the functions that you can use in collaboration with that to do some incredibly powerful things in the Revit and Civil 3D environment when you're pairing Excel with that. All right. I hope this was super valuable for all of you. For those of you watching this as a recording, I know that this was really long. The goal of this was to give you a ton of information that you can use foundationally in future webinars we're going to be talking about in this series. So for those of you watching this as a recording, thank you. I truly hope this earns a like and a subscribe on our YouTube channel if that's where you're watching this. And we hope to see you in future CTC sort of webinars live, if you can join us live, or back here on the YouTube channel would be great as well.